Here's a fairly straightforward problem, at least on A and B, that you should get right away. If x increases and the correlation between x and y is positive, then we expect a change in x to increase to result in an increase in y. So let's say that we say that the number of calories that you take in a day is correlated with weight positively. As you increase your calories, we expect your weight to increase. In part B, what happens when there's a negative correlation? In general, when x increases, y decreases. When x decreases, y increases. So there's a negative correlation in general between weight and exercise time. As your exercise time increases, we expect your weight to decrease. As your exercise time decreases, part B, we expect y to increase. So, part C, the correlation is 0. X decreases, what happens to y? The answer is we have no idea. We cannot predict y. We cannot predict what will happen with y based on what happens with x because the correlation is 0. When there's a correlation of 0, we don't know anything about y by knowing x. And in the other instances, we know something about x and y, and so we do want to know something about x, usually because it's cheaper to know that or more controllable. All right, part D, x increases, the r squared equals 0.8, what happens to y? Well, here, y is going to change. We expect that an increase in x is going to result in a change in y, and a pretty strong change in y. But we can't really say which way it's going to go without looking at a scatter plot to see what the relationship is, because r squared. What values will result in r squared of 0.8? Well, let's see. R equals 0.9 squared would give us an r squared of 0.8. A correlation of negative 0.9 will also give us an r squared of 0.8. So we don't know if we have a very, very strong positive correlation or a very, very strong negative correlation just based on r squared. We need to look at a scatter plot, a graph of the relationship between x and y to know what's going to happen.